Hello, everyone, and welcome to today's session on MLOps with Azure. Thank you for taking time out and being here today. I would like to introduce today's presenter, Srijit S. Srijit is here to talk on what and why of MLOps, deep dive into Azure MLOps capability, and further show us how to build a fully automated training and deployment pipeline on Azure. Srijit is lead data scientist with Taven Technologies and has enormous experience working on machine learning projects as well as building high performance data engineering pipelines. He is also a subject matter expert in designing and building natural language processing and real time streaming analytics systems. Prior to Taven, Srijit has worked with Cognizant, Algotree, and few others. Please join me in welcoming our speaker and over to you, Srijit.
Yeah, thank you very much, Srivatsan, for a wonderful welcome session. Okay, so first we will start with the Azure ML ops, right? So this is the agenda for today. So we'll just briefly talk about what exactly is ML ops, and then we will get into the components of Azure ML. Then we will walk over the how to bring a complete automated pipeline with combining Azure MLOps plus DevOps. Then we will go into a live demo of a fully integrated or fully automated end-to-end CI/CD pipeline on top of a machine learning project. Right? Right. So MLOps is a short form of ML operations. So MLOps is an end-to-end lifecycle management of an ML project. Right. So this MLOps is the term which is coming up in today's world, and most of the people think that MLOps is equal to DevOps, but it is not. MLOps is a very broad category which talks about adding most of the process and structure into a machine learning project so that we can efficiently manage and organize a machine learning project, right? So if you look at this slide, right, typically these are some of the concerns or process which are lacking in a typical machine learning project, right? Say the first part of the thing is code management. So this is a normal standard process in any software development, right? So but as we know that data scientists usually don't care about the code management in a Git repository or anything. So their development environment is simply just a Jupyter notebook, and they do all the code management or writing the code, everything in that local machine, right? So we don't usually connect to a Git repository and sync up with that Git repository in terms of the code management. So that is one of the pain point which we are going to address in MLOps. The next part is data management. So as we know, here the data means the data which you are going to treat in our model building pipeline, right? So assume that you got the data, or data engineering team has brought in the data from an external source into your premises, and you have the raw data, and assume we have the raw data, and then we do some cleaning and pre-processing in the data. So we have a new format of the data, pre-processed data. Then we do EDA, and we have feature engineered data, and then we will split the data into train and test, right? So we have different types of data, right? Raw data, feature engineered data, pre-processed data, and train and test splits. So often in a data science project, right, one of the major problem is how to manage this data, right? We usually do management of this data in a local directory, nothing more than that, right? So we keep track of all these things within different directories or subdirectories, and that's all about it, right? And when we are getting this kind of an incremental or full data, it is very difficult for us to manage this data with the proper versioning and with the proper information, right? What exactly that data is all about, right? So it's the different persons will do different types of data management. Some people will store everything into their local repository, and they will keep some information in a notepad or an Excel sheet, wherever it is, for just reference. But it is not in a central location, right? And it is not in a completely organized way. So the data management is one of the pain point in a machine learning project. After data management, you can see the model building part, right? So when we are getting into the model training part, model building is an iterative process, right? So when we train a model with the different hyperparameters or different algorithms, we need to log the metrics, we need to log the logs of that each run, and we need to log the parameters, outputs, or the plots which we are generating as part of the model training. Everything we need to log, right? This is also one of the pain point. We usually do it within our local machine, and we log all the things in our local directory, and it is very difficult to manage, and it is very difficult to trace what has happened last month, right? So if you wanted to go back to a previous experiment and see all the logs and metrics and artifacts associated with that experiment, we haven't logged that kind of an information. So it is very difficult to go back and have a traceability of the experiences, or sorry, the experiments which we are doing in the model training part, right? So that is also one of the major problem. So ideally, the model training has to be in a central location, and we have to log all the details about that model training in terms of metrics, logs, artifacts, hyperparameters, outputs, everything into a central location, so that at any point in time we can go back and refer that, and we can organize it in a better way, right? As part of the model building also, there is a provisioning of the infrastructure also there, right, where we need to train our data, train our model. So we need to create a virtual machine in terms of a CPU or GPU, and we need to do that, right? So that is also happening in a completely offline mode, so that also we can manage in the MLOps cycle, right? Once we have the model building, the next phase is model management. So how to organize these models, right? See, if you are in an organization where only you are dealing with one or two models, this model management is not a big deal. But in a bigger organization, when you are building different models and many of the versions of that model is in production, and how to manage this model in an efficient way? How will you know that out of all these models, what is the current status of each versions of that model? How to get the statistics of each model which is deployed in production or something, right? So all these things has to be transparent and visible to the business or to the data scientist team. Then only we'll be able to manage it properly when you are building a lot of models, and when you have a lot of different versions of the model, right? So that comes under the model management phase. The next thing is model profiling. This is not a mandatory step. So we do model profiling as part of MLOps. This model profiling, before we deploy the model into production or any environment, right, we need to identify what are the memory and processor requirements for that model. So this will help us in sizing our infrastructure for deployment. So we do a task called model profiling just to make sure what is the minimum and maximum memory and processor requirements for this model, so that we can go to the next step and we can size our infrastructure properly in the deployment side. The first series, or the first all this task, right, all this process or all this task talks about the MLOps on the integration side. So continuous integration side, starting from the code management to model profiling, you will be able to build a continuous integration pipeline on top of this, which will be seamlessly integrate each of this process, right? The next phase would be the deployment phase. So this part talks about the deployment. You have a model which is already created and which is registered in a model registry. We profile the model and we find out what is the memory and processor requirements. The next thing is governance, right? So we cannot simply put a model into production or UAT without approval, right? So there should be a governance process where we can enable this kind of an approval process, and using that, somebody can accept or reject our model based on certain baseline parameters which is defined by the business. So that governance part can be included in our deployment pipeline, right? And the next part is after the governance, right? After a model is getting approved, then it will go into the model deployment part. So in the model deployment, right, there should be an automated deployment. We have to provision the infrastructure that can be done offline, or that can be done in a CD pipeline. And we might need to do the endpoint versioning or the traffic management which is coming to that model, right? So traffic management is not applicable to all the models. Some models we have to maintain different versions of the model in production. So at that point in time, we will tell that 60% of the traffic go to the model version 2, and then remaining 40% will go to model version 1, so and so. If there are not multiple versions of the models which is available for the same model, then this traffic management is not required, but endpoint versioning is required, so that will help us if something goes with the latest version of the models, and if we are keeping the endpoint versioning of that deployed model, then we can fall back to previous versions and we can continue our operations, right? So once we deploy the model, right, there can be some kind of a smoke test, just to make sure that, because assume that this is an automated CD pipeline and model has been deployed and a REST endpoint is created. So before we share that information or that REST endpoint to the application team for an integration or something, it is always good that we test that endpoint, right? Whether the endpoint is healthy, if it is working or not, just send a sample request and just check the response, right? Is it a 200 request or something? This is just to make sure that the deployed endpoint is working or not. So as part of this smoke test, you can also include some of the positive and negative unit test cases based on your predictions. You can include some positive predictions and negative predictions with respect to your model input data, and you can test, right, whether everything is working fine, your endpoint is live and it is working fine, and predictions are also working fine, right? So once we have the smoke test or the testing of the endpoint is done, then the next phase is data capture, right? So this is a very important step. So because we have deployed the model in production, real-time data is going to come in. So we have the real-time inputs and the real-time predictions are there. And data capture is the capability where we need to enable data capture at the model endpoint level, where what it does is it will capture all the inputs and model predictions or whatever details which you wanted to capture into a central location, so that this we are capturing the real-time prediction from the model with the input, right? So this data will be heavily used for the next phase called a data drift monitor, right? So this is a post-deployment activity, right? So in order to perform the data drift monitoring, we need to capture the data, real-time data, which is coming to our endpoint. And data drift monitor is nothing but uh, we need to check the model's performance. Is it going to degrade over a period, right? So there might be a lot of scenarios like data quality issues will come in terms of real-time data, or the data distribution might change, and we need to test the model consistency over a period of time with the different types of called out data sets in real world. And there are a lot of feature attribution changes which we haven't seen in our training side, right? So all these factors affect our model's accuracy or the model's performance over a period. So drift monitor will help us in identifying that kind of an early indications of that kind of a model degradation, and we can create a notification or alert to the corresponding stakeholder, the data science team or the corresponding whoever is the stakeholder. We can intimate them and they can take proactive actions based on our notifications based on this drift indicators, right? So this is the typical machine learning pipeline, or at least what I'm going to automate with Azure MLOps and Azure DevOps CI/CD pipeline. So almost all these steps will be completely integrated within Azure DevOps in the upcoming demo. Okay. So these are some of the Azure ML components. Just to give you a brief understanding, there are different kind of terms and terminologies which Azure ML uses within their machine learning workspace. So just to have familiarity with that, because we might be using some of these terms in our live demo, so that just to get a brief understanding of what exactly it is, there's a concept called workspace. Workspace is nothing but a logical abstraction of all your artifacts, which is related to that machine learning project. So it is, you can think of it as a project. It is the root at your hierarchy. Okay, so workspace is at the root level. So this is just like an abstraction of all your model experiments, model artifacts, or all your machine learning project artifacts. Next is a compute target. What they call it as compute target is a virtual machine which is used for training and development. We can provision this compute target on the fly within the CI pipeline or a CD pipeline, or you can create it offline and you can refer it in our CI/CD pipeline. Another abstraction what they have done is data set. They call it as data set. Data set is nothing but it is an abstract API on top of all the data services from Azure, right? So data, be it a data lake or be it a blob storage or be it a synapses or be it an SQL server, whatever it is. In machine learning, Azure machine learning, they call it as data set. So using data set, you can easily create a reference to all these kind of an external data sources, so that in your machine learning workflow, we usually refer this data set and they will manage all the connectivity and all the authorization to get the data from all these external sources, which is supported by Azure data services. So this data set will manage that. So it means there is no need to get the data from a data lake or data blob storage or something, right? You don't need to write your own piece of code to bring the data from that kind of a source system to your workspace. That is not required. You just create a data set by referring to that kind of a data sources, and data set will do that magic of bringing the data without having much level of understanding about all those kind of external systems. There will be a term called experiment. Experiment is nothing but a logical grouping of all your runs. Or say we know that, right? We have different iterations of your model training, right? So one iteration is, you can call it as a run, right? One iteration is called it as a run. Along with the run, you will have different types of hyperparameter, different types of arguments, and different types of algorithms, etc. So that is called as a run. And when you organize multiple runs together, it is called as an experiment. Okay, so say assume that you are going with a traditional machine learning project, and you wanted to try tree-based algorithms, right? So tree-based algorithms is one experiment name. Inside that, you can try decision tree, random forest, and XGBoost kind of algorithms, just to organize in a logical way. So run is each of your iteration, and multiple runs can be combined as an experiment. Then comes model registry. Model registry is nothing but you once you select the model, or once you find out what is the best model for your problem, then you can register that model into model registry. This is the final step of a CI pipeline usually. So we take the data, we build the model, and we register the model into model registry. Then we call it as model profiling. It is nothing but before we deploy the model into production or into any other environment, we need to identify the memory and processor requirement for that model. So in model profiling, what we usually do is we just send some sample requests, say a number of requests, right? So 5,000 or 10,000 requests, we will send it to a particular model, and then we will find out what are the system requirements for this model to run, right? So that will help in sizing our deployment infrastructure. So model profiling, it is not a mandatory step, but it is good to do this model profiling. That will help definitely in the model deployment infrastructure sizing. Then model deployment, we deploy the model as a REST endpoint. That is model deployment. Real-time data capture means this is an important step for the next phase, data drift, right? We need to capture all the input data coming to our model or the endpoint and its predictions. This will help us in identifying the data drifts. And there is another component called the data drift, where we can identify different types of changes which is happening in a real world with respect to the data, and we can notify a data drift. We can set some threshold for different types of quality issues or something, and we can inform on a real time basis. We can inform the people who is the owner for this action, and they can take proactive actions. So this is typically an architecture. If you talk about the code repository is integrated with the CI pipeline, Azure DevOps CI pipeline. This is the architecture which I followed when I built this demo. Okay, and data right now we are focusing only on a CSV file, but this data source can be anything. It can be a data lake, it can be a blob storage, it can be Synapse, or anything. Any data services supported by Azure is supported here, and you get the data and put it into Azure blob storage and create a data set, and we refer this data set directly in our machine learning experiment, right? So that's what I told you earlier, that data set is an abstract. So in our machine learning experiment, we will not connect to this blob storage directly, right? So we send the data to blob storage, and we created an abstract data set, and we refer data set in our further experiments. We don't have any connectivity to blob storage directly. That is not required when you create a data set in Azure ML, right? So, and coming to the model training part, here you can see that you have to create a compute VM, which is your training machine. And this we can use Azure built-in algorithms, or we can bring in any external libraries into this model training part in Azure ML. And this experiment can log all the experiments, and it's run all the outputs, metrics, logs, whatever it is, right? So whatever the artifacts which is produced by our training script, everything can be logged in Azure Machine Learning Workspace, and it can be easily managed and organized, right? So this model training part is happening in a compute VM. That is our training machine. It can be a standalone machine, or it can be a distributed machine. So that also you can configure when you are creating your CI pipeline. So once we have the model training part, then what we do is, since we split our pipeline into CI and CD, so this model training is then done, and we got the best model, and that is registered in the model registry. Then the next part is we store all that configurations and everything, which is inference configuration and everything, which is required for the deployment pipeline in the DevOps pipeline artifact. So this is the scope or end of the CI pipeline. So starting from the code repository and the data, get the data and sync up with the code repository, model training, log all the things which corresponds to that particular experiment, and then set all the configurations meta files which is required for the deployment to the DevOps pipeline artifact. Right. So in the CI pipeline, as you can see that we were able to manage the code. So code management is happening through the Azure repos, and data management is happening within the workspace. I will show you how. And the model building is also happening within the Azure machine learning workspace, and model management is happening through the model registry with the proper versioning. Unit testing, I haven't included unit testing in our CI pipeline, but you can include unit testing as well. But this unit testing doesn't mean that it is exempt your model training and evaluation. You still have your model testing and evaluation. So whatever the other code which you have written in terms of some data quality checks or data filtering checks or something, you can bring in some unit test cases. This is not related to the model training and model testing. And then model profiling, right? In our upcoming slides and upcoming demo, I will show you how all this MLOps concepts or process, right? All these standards has been incorporated within the CI pipeline. Right? Once we have the CI pipeline, we go with the CD pipeline. In the CD pipeline, what we do is we take these artifacts which is stored in the CI pipeline and we deploy it into Kubernetes, Azure Kubernetes or Azure Container Registry. Since I'm using Azure's free subscription, I'm not able to use a Kubernetes service. So I will show you how you can do it in a container registry. But in production, we usually don't suggest container registry based deployment because that is not reliable, right? So you have to go always with the Azure Kubernetes. But I will not be able to show you the Kubernetes side, but I can share you some of the information related to how you can deploy it in Kubernetes. There is not much difference. Okay. So what it does is the CD pipeline or CD pipeline will create a REST endpoint and enable the data collection, and data drift is the post deployment part. So this also I will not be able to show you because data drift is enabled, data collection and data drift is enabled in Azure only for Kubernetes based deployment. So since I'm using container registry, I might not be able to show you data collection and data drift because of my free subscription. And in my CD pipeline, as you can see, the deployment and governance will be covered in our CD pipeline, and the data capture is covered, and the data drift, I will show you how it can be done. And here is the demo, what we can show you. Yeah, I will show you the demo. So I'll come to this DevOps, right? So first, what we need to do is I have already open sourced all the work which is happened on this MLOps Iris. Here, what we are trying to do is we take this Iris data set, and we all know what is an Iris data set. Here, my objective is not to build a best model for Iris problem, species classification problem. My objective is to bring an MLOps plus DevOps together. So you can see in my repository all the code, commands, artifacts, CLI commands, and all the screenshots, everything which is used in this demo. So you will be able to easily replicate this thing, and you can just get into Azure and you will get a free subscription of 1 month, and you can easily replicate whatever we are trying to show you today with this open source project. Okay, everything is here, right? The first thing is you have to create you have to get into Azure DevOps, and you have to create a project, right? So MLOps Iris is a project, right? And when you're creating a project, I will just simply show you what it takes. We can give descriptions and everything. Create a project. So once you create a project, the next step what you need to do is you are going to build some pipelines, right? So come to pipeline, and you can create a pipeline. And here you are going to integrate your code. This is the part of code management comes into picture with our CI pipeline. So you can select any of the code repository. I'm going with Azure repo, or you can bring your code from any other Git based code repository. But Azure repos, this DevOps pipeline, Azure DevOps pipeline comes with a repo. So inbuilt repo, so you can use that, or you can bring in your uh, code from other repository as well, right? I'm just going with the repo, right? I'm just creating an empty job, right? So here, this is the CI pipeline, right? So you have different agent jobs, and you can see all these things, and you can simply add this kind of a task, right? So Python, you can search it here. Use a Python version and all, right? So this I will show you in my pipeline. But before that, I just create a project in DevOps, and you have to do something. This is important. You have to create a service principal. Uh, you have to get into the project settings of your project and get a service connection. Go to service connection and create a service connection, and then you use Azure Resource Manager and just create a service principal. Because this service principal, we are going to use it extensively in our CI and CD pipeline. Without this service principal, the CI and CD pipeline will not be able to authenticate your pipeline, right? So to do that authentication, you have to do this. I forgot my password. Let's see. So you can create a service connection like that. Okay. So it's nothing but selecting a resource group and creating a service connection. So that is only step prerequisites that is also mentioned here in this repository. You can see that you have to create a service connection by this. Once you create the service connection, you can go to creating a pipeline. So this is an already created pipeline, right? So yeah, here you can. There are variables. These variables are nothing but the arguments which are getting passed to the CI pipeline, and you can define the variables in the variable groups. If you have a set of variables where it can be used across your pipelines, you can create it as a variable group, so that you can just create a variable group here and refer it in your pipeline instead of duplicating that variable names over and over in different CI pipelines, right? So you can create a variable groups. I have created a build variable group here, right? And you can see that these are my arguments, and here I'm just mentioning, right? So what is the compute machine which I required? What is the name of the compute machine? What is the VM size? So this size is supported by Azure, and which region I need to create the VM, right? Which resource group I am using for the CI pipeline. This is my resource group, and the workspace name. So I have created a workspace name as IRIS workspace. Let's change it to one, right? Yeah. Okay, so I will come to the pipeline again. This is the already built-in pipeline. I will just run this pipeline because this is what it does is, show you. Yeah. So in this pipeline, what it does is different steps are applied. I'm using a Python 3.6 version, and I'm installing the dependencies, right? So this dependency install requirements.sh file is already there in the repository that you can see here. Environment setup, install requirements.txt, right? Install requirements.xh. So I'm just creating installing Azure CLI and Azure ML SDK and PyTest for you doing this unit testing and everything. I'm just installing the basic Azure ML Python libraries and Azure CLI there, right? So I'm installing that, and the next step is I'm going to use Azure CLI machine learning extension. So Azure ML comes with the different SDKs, right? You have Python, C# SDK is also there, and similar to that SDK, Azure CLI is always there, and Azure CLI is having a machine learning extension. So whatever we can do with that Python SDK can be replicated same with the CLI commands as well. So I find it useful because there is no Python programming understanding is required. So considering that a DevOps person is coming here and doing all these things, right? So it is better to ask him to do something in a command way, right? It is easy for him instead of writing a piece of Python code for doing this thing, right? So I choose Azure CLI machine learning extension for this, right? Right, and here you can see that, right? So we have created a service connection, and that service connection has to be linked to all these kind of steps. Sorry, in order to execute this. So installing this machine learning CLI extension. Then the next step is I'm creating a workspace, right? Workspace is the abstract of our machine learning project, right? So I'm just creating a workspace, and while creating the workspace, you can see that I'm creating the workspace using the CLI commands, and I'm passing the resource group. All these arguments you see that we defined already in the variables, right? So it will take the values from the variable groups and it will put it here. So it will create a workspace for me. That's the first step. The next step is I need to create a compute VM for to execute my training script, right? So that also I'm using it. It is also, you can see that create or use. If it exists, it will not create. If it doesn't exist, it will create. Okay, so since my workspace, what we have provided here is not there, so I already have a workspace, but this is a new workspace which is not there within my Azure account. So if I execute this, it will create everything. So in the compute target machine, same way we are using Azure Machine Learning CLI and providing all the required arguments, what is the VM size, minimum node, maximum node, all these arguments coming from the variable groups which we defined. The next thing is we have a data. Right now, I just put this data into a local folder. So I'm not going to refer this iris.csv in my training script. What I do is I will upload this CSV file into Azure blob storage and then create a data set reference and use that data set reference in my training script. So that I'm not referring anything in my local machine, right? So I'm referring anything in a from a central location. But this can be part of your CI pipeline, or you can do this step before you come here, right? So it means you have a data, you can upload this data into blob storage and create a data set and refer that here, or you can keep that as part of the CI. It can be taken out as well, right? This step. Then using this bash script, whatever you wanted to create, right? You just have to click on this plus and say bash. So it will come, a bash task will come here and you can do whatever it is. And CLI, if you say, you can see the Azure CLI command step will come here and you can add it in your pipeline. So here in this step, I'm just trying to create some folders. This I need to create it just to keep some of the artifacts coming from our training. In the iris training task, I'm executing an Azure CLI command and providing all the programming arguments and the CLI arguments here, right? I'm just executing. I'm sharing a training script here. I will show you how the training script will look like. It is exactly same. I'm using scikit-learn and taking this data and training it using Randa Forest, I guess. Yeah, I have just taken this code somewhere, right? So I haven't written this code. So I think it is using Randa Forest, I guess. Yeah. Decision tree classifier it is using. I'm using scikit-learn only, and but we are executing in using Azure ML SDK. So we are more or less, our training script will be exactly same as a normal scikit-learn training script, but we are just trying to integrate it with Azure ML SDK, right? So the training is happening, and then the final step is we are registering the model into model registry, and this copy files and the published pipeline artifact is required to get all the artifacts from this compute VM machine back to this CI pipeline, so that we can make use of this files which is generated by the CI pipeline in our CD pipeline. Right? I will just quickly execute this. If you come to my portal, right? So this is the Azure portal. I will not be able to see, there is a workspace, but I will not be able to see any workspace called demo. It is not there. So we are going to create this workspace. So here, one thing to remember is we are going to create a workspace. We are going to create a compute target machine within the workspace. We are going to execute our training script, everything on the fly from this pipeline. Okay, so we are not going to do any manual activity. Just have to run this pipeline. It might take 10 to 15 minutes. So I'll just start this pipeline. Okay. So once you start this pipeline, you can see that you can see for each step, you can see the logs, what is happening and the status of it, whether it is successful or failed. You can debug all that information here. It is queued, let it run. Okay. Right. So it is starting, right? So you can see that each of our pipeline steps has been executed one by one. You can see the status of it. So now it is installing all the Python dependencies, which I referred. So let it run. So we will just go to the structure of our training script or the code. Sorry. So here you can see the training script. You just have to create a training script using any external libraries. And we have to bring in Azure ML SDK as well, Python SDK, and some of the abstract from that. We are going to use workspace, data store, data set, and everything. Right. Yeah. So the program starts from create pipeline, and you can see we are passing a lot of parameters, command line arguments, program level arguments as well into this program. What is the container name, where we are expecting our blob storage, what is the name of the input CSV, you can refer it there, dataset name, dataset description, model path, where should I keep the model, artifact location and everything. So if you go back and look at our pipeline, you can see that in our training pipeline, right, we have referred all these parameters, right? So you can see that the container name, input CSV, the model path, all these things are actually programming arguments. So this is the advantage, right? You can combine all these things along with Azure ML CLI. So it is completely organized and managed. So you have a create pipeline. What it does is, here you can see that I'm getting the data, which is already uploaded by this pipeline to blob storage, and I'm getting the data and creating a data set. And Azure ML has easy way of conversion of between your data set to pandas data frame and vice versa. So you can work on it very easily. So right now it is supporting tabular format and the fixed width format files right now. So along with that, you can convert it to data frame and all. Right. So we are just doing the basic scripting, right? So splitting the data, uh, fitting the data, training the model, and dumping the model, right? And just validating the model with the test data set, right? Normal procedures in the machine learning project, right? But here you can see that we are using some of the parameters from Azure. Here in the initialization, you can see I'm getting the context. So this will give me the understanding about what is the workspace which I am referring to from the CLI, what is the run which is correspond to that. And if I make any log or anything which is respect to this run, it will be logged in my run. So here you can see that I'm logging metrics here. I'm logging precision, recall, and accuracy into my run, right? And here I'm creating a confusion matrix, and even I'm creating a plot, a PNG file, and I'm even logging the PNG file, the confusion matrix also into my run. So this I can show you how it will look like once we execute this CI pipeline and once we execute this training as well, right? So here I'm logging all the uploaded files. Like you can log your metrics, you can log your files also. The plots also you can log, or the output files. So I am creating a prediction CSV file where I'm keeping the actual and predicted and the inputs, and I'm creating a CSV file. And this also I will upload into this corresponding run. We can see that in our workspace once we execute this. Right. You can see the create output part also. So all these things, it's more or less same. There is not much uh, complexity is in migrating our existing training script into Azure ML. It is pretty straightforward. Now in the environment setup part, right? So this is what, right? We can bring in any kind of external libraries, or we can use Azure's inbuilt algorithms, and you can refer all your not this one, Conda dependencies actually. So I'm using Conda dependencies, and a Conda dependencies. You can provide a configuration, name of the your Conda environment and the channels and the Conda dependencies, what you need to install in that Docker. Ultimately, it is creating a Docker and all the um, external libraries which you need to install, right? So I'm installing scikit-learn and all. So what it does is, it is in the pipeline. If you look at it, based on this conda reference file, it is creating a Docker, and it is, let's say, pipelines. Yeah. So this pipeline is getting executed. Right. So yeah, they're all, many of the steps has been already done right now. Right. So what are the steps completed? We installed Python, we created a CLI, and we created a workspace, and we created a compute target machine on the fly, and we uploaded the data. Right. So right now created a metadata, and right now this iris training step is happening. Let's go back to our portal, and you can see right now iris workspace demo. Yes. So previously it was not there. Right now it is created by our CI pipeline in an automated way, right? So once you click on that, you can see basic information within a portal, and you have to go to this web URL, studio web URL. And when you are creating a workspace, right, you will always get a default blob storage. So if you wanted to see any files here, you can, we are actually using this blob storage, default blob storage. And in the storage explorer, if you come, you can see the uploaded CSV file, because in our pipeline run we have taken this data from this local and uploaded into blob storage and created a data set with a version, right? So that is already here if you look at it, right? Yes. Here you can see that iris data is the data set name which I provided, and inside that you can see the iris.csv is already there with all the meta information. Okay, right? So we are going to refer this iris CSV from here in our training script, and this is also happened in an automated way. Now, okay, yes, this is our workspace. The workspace looks like this. On the left side, you can see all the assets and manage, and it's organized in this way. So under the data set, if you go to that data set, we don't have any data set right now. It will create. Okay. And in the experiment, if you come, since our iris experiment is running, this iris training is happening. You can see iris training is happening. And in the experiment, you can see iris experiment is the name which I provided for this experiment, right? So it is created and it is with the proper version, right? Latest run is 1. If I execute it the next time, it will come as 2. Right? So once you click on this experiment, yes, you can see different runs inside that experiment. Right now, there is one run 1. It is in a sequential way. We cannot manage here. So Azure will create run 1, 2, 3, 4, etc. like that. And here you can see overall how many experiments and how many runs has been executed within this under this experiment, and what is the failure rate, the status of it, cancelled, completed, all this basic status, and the duration of each experiment to run, all those basic statistics you can see. You can add different chats as well, right? So once you go to the run, here you can see, right, the basic information about that experiment or the iteration, and you can see the compute target it is using, and the training script it is using, and the program arguments which we passed as part of our CI pipeline. Everything is linked, and the environment iris demo is the name of the conda environment which I provided in the in this conda dependencies file, right? So that is linked, and so we haven't registered any models from this run. So once this run is getting completed, you can see registered models as well. And here you can see that the git repository, it got the code snapshot and it is executing. That git repository is referred here, and the commit of this will be always a latest commit, so this you can change. So the commit where this triggered, the CI pipeline is triggered, everything is shown here. Metrics and all will come. Okay, so how it looks like, I will show you. So once this is in a in progress stage, once it is getting completed, I will show you a complete workspace. Let me duplicate this. Right. So we'll go back to my previous workspace, not this workspace. Okay. So right. So this is the workspace which I already created. So here you can see a lot of information, completed information. So here you can see there is a data set registered with a version, and this data set is connected to this blob storage, right? So that link is already established, and all the other information, and you can add different tags, right? So I just added a format as CSV. You can add multiple tags to understand what exactly this data set is all about, right? So data set is created, and you can see my experiments. I have executed 14 runs or 14 iteration within this iris experiment, and you can see it here. Once I go to the experiment, yes, you can see different run, the status of that runs, and when it is executed, where it is executed, and what it is all about, right? Different tags. I have just provided it as iris classifier, final run, something like that. So this is all for our understanding purpose, for trackability purpose. You can add your tags here, right? And once you go to the final run, I will show you how it looks like when you complete your CI pipeline, right? So this is a completed status, and you can see all the information here. Yeah, here you can see that which input data set is referred, right? So it means which input data set is used for this training. So you can just click here and go back to that. So as you see, right, all this lineage, right, which data is used for our model training, where it is executed, all that kind of a lineage is established here. So it is completely manageable. And in our program, right, so in our training script, you can see I logged three metrics: precision, recall, and accuracy as part of this run. So that comes here, right? So you can see metrics. I had logged this three, and you can see the whatever the accuracy, precision, and recall here. That will come under the metrics. And yeah, I told you that I created a confusion metric PNG file as well, right? And I just uploaded. So that also you can see here under images, you can see a confusion matrix here that is already uploaded to this run. You can download and see. So I just need to zoom in. So font size is very small. Okay. So you can see, right? So ideal. Yeah. So here you can see that the confusion matrix is plotted and the confusion matrix is uploaded to my run, right? So, and you can see that here under images. So if you wanted to upload any of this kind of a plots, you can do that with Azure ML. You can just attach many images into your run. Child runs we are not using, because if you have a pipeline or something, and if you wanted to do parallel kind of a runs or execution in a sequential way, you can go with the child runs. We are not using child runs. And inside output and logs, you can see all the logs associated with this training, right? You can see in my training script, I am just creating some print statements by just to see what is the data frame look like for that iris data, and what is the model score. Some of the print statements I'm doing, right? So all those things you can see it in the logs, okay, under outputs. And also you can see in my training script, I'm creating a CSV file, which is nothing but the prediction with respect to test data, right? So yes, create outputs. So here I'm creating a CSV file that contains the actual species and the predicted species. This is just to check offline that what is happening with the model, right? So I created a CSV file and I just uploaded that CSV file as part of this run as well, right? So here you can see in the output, you can see the CSV file, right? Confusion matrix also I printed it as a CSV file. Uh, and even the predictions also I put it as a CSV file and uploaded it my run. You can see the input parameters and the actual and the predicted one. This is just to check offline what is happening with our prediction with respect to this data. So I'm just showcasing all these possibilities just to show you that what is the capabilities of Azure ML. Right? So you can log all your plots or you can log any type of an output files. Right? So that is the intention of this. So this is a confusion matrix. I just put it as a CSV and attached it. Snapshot. So snapshot is the code snapshot, which is used for the training, right? Say this is that version of at that point in time when I executed this CI pipeline, it will take a snapshot of the code repository and it will keep that snapshot as the run. So that this is not the latest version. Okay, so this is the code at that point in time when I executed this run. So this is very useful when you wanted to go back to some of the previous experiments and previous code. You can just go back to this run and see the snapshot. This is the copy of the code repo at that point in time when you execute this project. Right? You can add model explanations and model fairness as well, but I haven't added anything right now. But inside your training script, you can use that by Azure ML. You can create a model explanations and you can log that model explanations here in your run, and even fairness also you can log it. So as you can see, right, everything is completely organized and it is completely centrally managed, and there is no need to locally look at all these things. A lot of information is organized and managed properly with the proper lineage and everything, versioning and everything, so that it is very easy to organize, manage machine learning projects, right? That comes to the CI pipeline, right? So as you can see, the compute target machine, yeah, here we created a compute target machine, right? So not here, workspace demo. Yes, we just created a compute target machine, and that target machine also we can see it here. Go to compute, and you can see compute cluster. We can see Iris compute, right? This is just created by this pipeline which we executed just now, right? This pipeline, where is that pipeline? Yes, this pipeline, we created a target machine, right? So this target machine is created based on that. Yes, here you can see, not here, which, yeah, here. And similarly, when you are deploying your model, right, you can create inference clusters. It can be an AKS machine, something. ACI container instances will not come here. So if you create an AKS cluster, it will be listed here. Or you can create a virtual machine offline and attach it to your workspace and refer that in your CI pipeline. Any way you can do. It doesn't mean that always you have to create all this, provision all these resources on the fly. You can do it in an offline as well, right? That is also possible. So in the data stores, you can see all the blob storage related information, where it is kept and everything. Okay. Yeah, I will show you once we create the model, right here. Once we create the model and register the model into the model registry, that is the end of the CI pipeline, right? So I will show you how it looks like. If you come to models, and you can see different versions of the model. Iris is the name of the model which I provided with the different versions of the model and different tags, model based on decision tree or whatever it is.
You want to take some questions, Srijit, maybe before that is running?
Yeah, yeah, sure.
Yeah, so let the run complete. Let's take some questions. Or
Yes,
you have
yes.
anything else to show, Srijit, or do you want to take questions now?
I want to show the deployment pipeline as well.
Oh,
I
okay, okay.
quickly cover the deployment pipeline and come back to questions. Okay.
Okay, that's fine. That's fine.
Okay. So you can see that model registry where you can click on that and you can see the model registry part of it, the models, right? So you can see the version of the model, you can see the name of the model, the framework. I put it as custom, but you can put it as scikit-learn or whatever it is, and which experiment has created this model, which run has created this model, descriptions and all the properties and tags for the understanding purpose. All these things can be under this models. You can download this model in the artifacts. You can see a pkl file. This is a model. You can do it in offline as well if you wanted to test something. And this endpoint will tell you based on this model iris 9 version, is there any endpoint or deployment created. So we created a deployment with this name, service name, and this is referred to this iris 9 version that is also shown here. So if you have a model where no deployment is done on that model, then this link will not be here. So everything, model explanation, fairness, which data set is created, everything is linked with the models as well. Now we will quickly go to the CI pipe. Yeah, here you can see the everything is done. And if you come to our workspace of Iris workspace demo, you can see the models and everything is in place. Right? So you can come to models and you can see the model version 1 is created. All these informations are provided here. If you come to experiment, and you can see the run and its logs, right? So the metrics, measures, outputs, everything is logged, right? So the CI pipeline is completed successfully. Now the next part is our release pipeline. So we need to go back to the release, right? In the release pipeline, same way, we need to create a pipeline, right? Okay, so I'll show you quickly. So release pipeline typically looks like this, right? So we have an artifact which is created from the CI pipeline, and we store that CI pipeline artifact inside the CI pipeline, and we refer that artifact in our deployment pipeline. That artifacts, you can see it here. If you go to the pipelines and you go to the run, you can see the artifacts here, right? So if you click here, we can see all these artifacts which we are going to use it for our deployment. Right? So in our deployment, we need configurations where we are going to deploy. Right now, we are going to deploy into container instances because since my subscription is free, I don't have any provision to put it into Kubernetes. So the deployment, typical deployment of a container instance looks like this. You just have to specify the number of CPUs and basic memory. A typical AKS deployment configuration looks like this. You have to tell what is the minimum replica, maximum replica, what is the target utilization, right? So if I say 80, then it will, if the target utilization process 80%, then it will spin up a new machine, something like that. So we need to say data collection enabled true. This is for our data drift, memory and CPU requirements and everything. So everything is available in that code repository. You can just go through it. And this conda dependency file talks about what is the external libraries required for deployment, right? So all that external dependencies and Azure machine learning SDK and everything, you can keep it in the conda dependencies. And you have to create a scoring script, right? So that score script will looks like this. There is a template. We have to follow this template. So there is no need to create a Flask or Falcon application on top of this. That Azure machine learning will do it for you. But we have to follow this template of scoring script. There should be a def init function where you can init, where all your init, model init and everything will come here. Right here also, you are not referring this model from the local repository, local directory or something. When this score.py runs, right? So it will connect to our workspace and it will connect to this model name Iris, and it will, if you don't specify the version of that model, it will just take the latest version and it will download that model from this workspace, on the fly to to this machine where this scoring file is running, and it will load that model, right? So there is no reference of local things here in this. We are not referring the data locally. We are not referring the model locally. Everything is coming from that workspace, machine learning workspace, which is centrally located. And there is a definition run. There is a method called run, and here you will receive the raw data, and rest everything is like a normal Python program. You can define your own functions, and you can do whatever inside what has to be done with your input data, right? So I'm just taking the data, and I'm taking it in a JSON format. I'm expecting this 4 parameter from that JSON, and I'm just predicting that with the model. This model is loaded in the init function, and I'm just creating a response. That's what we are doing right now. So we have a run method, and we have an init method. We have to follow this template, and we can extend this with our own functions as well. So I'll quickly show the deployment part as well. So a typical deployment flow looks like this. It will connect to a CI artifact, and you have different stages. This is my UAT stage, and this is my prod stage. And you can create approvals, right? So pre-approvals and post-approvals you can create. So without this approval, this job will not successful, right? So here I created a pre-deployment condition. I created an approval process here, and post-approval also I created, right? So we can do that. And in a typical deployment job, right, it will look like this same. We are just using Azure CLI, and we are deploying the model using Azure CLI machine learning extension, and we are deploying it, and we are executing some test, right? So some smoke test has been integrated in my repository. If you could go to the smoke test part, what I'm trying to do is this: I'm deploying the model using a CD pipeline in a fully automated way, right? So I need to make sure that the deployed model is the endpoint is running fine or not. So I'm just doing some smoke test. Here I'm getting that deployed models URL automatically, and I'm just sending a dummy request, and I'm making sure that the status code is okay. So to make sure that the endpoint is running, and I'm just making a dummy request, and another test case is just sending that dummy request, and making sure that the prediction is working and the expected prediction is 1, something like that. So you can extend this, right? So once we execute the CD pipeline, right, so this also automated, and you can see, right, yeah, come to release, you can see the logs and test reports and everything. You can see it here, right? So here you can see I pre-approved it, but the prod part is waiting. The post-production approval is pending. So I can simply go and approve or reject it. Once I approve it, this pipeline will get continue. Otherwise, it is in queue. We can define all these things, and you can see the smoke test which is executed. You can see the report out of total 2 test cases which I have, right? So we have 2 test cases. Out of 2 has been passed. So we can say that you can just deploy the model like that. And once I deploy the model, you can see that in the workspace endpoint, you can see the deployed model. This is right now in container instance. If you deploy it in Kubernetes, you can see. I will not be able to show you that data capture and the data drift, because we need to deploy the things into AKS to enable those functionalities. So you can see the deployment status. If the endpoint is healthy and it is created a REST endpoint, so we don't need to create a REST endpoint or create a Flask or Falcon application on top of our scoring script. This Azure ML will create for you. We just copy this endpoint, and I have a test script where I'm just pasting that endpoint and sharing some dummy inputs to it, and I'm executing it. Yes, you can see that the predicted species output is 1, right? So we are getting the endpoint is functioning, and we are getting the information from there. You can see all the logs as well, right? In the deployment logs, you can see all the logs which is coming to that input. Right. So this is how. So if you look at the architecture, right? So we have a lot of MLOps standards. So we have enabled all those MLOps standards in our machine learning project using Azure ML, as you can see here, right? So all these MLOps standards are incorporated, and we build a CI/CD pipeline on top of it. So it is fully automated, right? So you can simply execute to create your infrastructure, execute your training job without going to that portal and creating anything manually. So this is how it works. So this is how we can create a fully automated, fully integrated CI/CD pipeline on top of an MLOps pipeline. So then it will be complete like that. So you can go through my repository, code repository, and I think I have replicated and put all the things what I have in my local here. So all the screenshot, different steps, the commands which I used in my pipeline, everything is there. But if you just try to see, since you have a free trial of 1 month from Azure, you can try, and if something is not working, just raise an issue, because I'm not sure whether I missed something here or not. Okay. Yes, I think that's all about my session today, Steven. Thank you everyone for listening. Thank you. Yeah, we can take some questions.
Yeah, thank you, Srijit. Actually, it was like a pretty amazing and insightful session. The reason is getting working end to end, right? Starting from your training, infrastructure, logging, everything covered, and also the deployment part. It was like kind of a very action packed session for 1 hour. Because most of the time, if you really see, like we run in silos, right? The continuous integration is one part, the continuous
Exactly.
deployment is one part. I'm also surprised with Azure's capability, because like I work with GCP, I work with AWS. I'm not sure, like GCP has that queue flow pipelines and all. It is a little complex. It's not like as easy as what we saw here, or maybe once
Mhm.
we get the hands dirty and go into the complex module, uh, it may be a different story. But they have managed it very well, integrating
Exactly.
the logging aspect of it, deployment aspect of it,
Mhm.
approval management. That like Azure has done a great job, and you have done an even
Yeah.
more great job showing us the end-to-end pipeline in this 1 hour. That was really like an
Thank you.
amazing session, Srijit. Let's
Thank you very much, Steven. Yeah.
no issues. Let's go to some questions. So one thing that the question came is does Azure DevOps comes with the free subscription?
Yes, you can use it for 1 month.
Okay. Okay. And will you be also sharing the presentation that you had initially in your GitHub? Is it already there?
Okay, my presentation is not there in the Git. I will publish it.
Okay. Okay. So there is a question from Rohit next. So Rohit is asking, in GCP, we have a model training pipeline in production as well. However, in Azure, we don't have model training in production environment. How both are different? Please, can you elaborate? So when you
Okay.
deploy in production, do you can you retrain the model, or you have to take it to development and do it?
That is no. Okay, so we usually don't. Okay, so I don't understand what you mean by training in production, because we usually do the training in the development side, right? So and we deploy the model into multiple environments, right? So, but production also you can try that. I did not get that question
So maybe
properly.
that it can be two-way, right?
Mhm.
One is maybe like we have access to production data. I think that should be
Okay.
possible. You can just connect to your
Yes. Yes. Yes.
production data
Yeah.
sources or create data set and then do it. The second aspect is maybe once you're trained it, if you want to retrain in production
Mhm.
with the production data, like once you're deployed it, I think again you have to. It's the same concept, right? You have to come to
Yes.
your
Yes. Yeah.
workspace or project that you created and rerun it with the new data
Yeah.
sources.
The
Got
different environments comes into picture when you deploy the model. So I don't think we need a production deployment for production training, UAT training. The development environment will be same, right? That's what I thought.
Got it. Got it. I think it's more with the data security. Maybe Rohit, if you
Okay,
have a
maybe.
specific question, you can message it. I think more like data security because a lot of time we don't have production data access in development and
Mhm.
UAT, right?
Right, right.
Maybe it's to do
Okay.
with it.
Yeah. So, if that is the case, right, you can do that, because if you look at the CI pipeline, right, so we are creating a machine. So that compute machine is created on the fly here. So assume that you don't have that kind of a flexibility to create your infrastructure on the fly most of the times, right? So the admin team or the cloud admins manage that. So assume they have a dev environment and they have a UAT and prod environment. What you need to do is you just have to refer that, you just have to create a compute instance, right, as I show you. So here, uh, the assume cloud admin team has created three development environments for you. One is for dev, UAT, and prod, and they can attach that VM virtual machine into this workspace, and you can refer that machine in your CI pipeline, so that you make sure that your development or the training is happening according to the according to different environments. Yeah, that is possible.
Got it. Got it. So the next question is again from Rohit. In Azure, we have notebook and there is also Azure repo. So where should we maintain our code repository?
Okay, so here I maintain my code repository in the Azure repository, right? See here, this is the Azure repository, and in my VS code, I'm connected to that Azure repository, and I'm doing that. I am not using notebook here, right? Um, because when you wanted to do this kind of a integrated environment, I don't usually prefer using notebook because that is not in an organized way. So I usually prefer, I will use to do notebook for EDA or some other stuff. So for training and that kind of a jobs, right? So I will use VS Studio code, and here I connected to that MLOps Iris repository, right? So I am in sync with my development environment and repository. So whatever I do here, I will just commit it and do the steps. So if you are using Azure notebooks, you can that also you can bring inside this code repository if you wanted to maintain that in your maintain and sync up with it. So, but I usually don't prefer notebooks when you are going with this kind of a training, because it doesn't seems good.
Got it. All right. So there's a question from Ravi. How do you handle data drift? Do you update the data set, blob storage as an example, and run training again? So, Ravi, I
Okay.
think here we did not show data drift, but let me rephrase this question, Sujit, a little bit, right? So, in Azure experiment, once you're running it, when in production, if you see a data drift, is there a way to re-trigger the training pipeline and everything?
Yes, yes, possible. So here you can see, right? Say, I created a data set. So we created a data set. So assume that this is the baseline training data, and you can create data set monitors using this UI or programmatically by selecting a target data set and a baseline data set, and you can set the monitor settings. Sorry, and here, right, so what we do is Azure supports data quality checks. What it does is it will they will say constraints, right? So they will take the constraints of each of your features from the training data, baseline data, in terms of your numerical and the categorical. They have different strategies, and they will create some constraints for you, and you can set a threshold. Say if the quality of this feature falls below this particular threshold, trigger an action. So that also you can do. So, but I am unable to show you that because AKS only supports that. My deployment is not in AKS. And Azure supports another data drift component called a feature. It can detect your data distribution changes over a period. So all that inbuilt functionality is there. So you just have to come here and configure your dataset monitors, and you can configure to whom I should send the notification if there is something going down, or you can set thresholds. Ideally for data quality, for each feature you can set the threshold. You can find out the similarity between your baseline categorical features and the real world data which is coming in over a period. You can do that, and you can even do the consistency model consistency checks by enabling the data capture and this data set monitors. There are pretty lot of good functionalities already there, and it is end to end. You can even trigger an action to notify some stakeholders, some data scientists or some business people, or you can trigger an action to um, uh, trigger an action which can run your CI pipeline as well. That endpoint that is already there. That sync is there.
Got it. So how about model drift? Like yeah, you showed us data drift, right? Basically, the data set, but the model itself can get drifted.
Mhm.
Possibly there may be not much change in the data distributions. So is that or there's also functionality to capture model drift?
If you go to Azure Drift, so right now this is in a preview mode. Okay,
Oh, got
so
it.
they don't have that kind of an. So what I find limited is right now they are supporting numerical and categorical feature. They primarily focus on the traditional machine learning or the tabular kind of a data. So if you have an image problem or if you have a text problem, right, that kind of a drift is not here. I think they might bring up some of the data drift aspect as well. right? So here you can, I will show you some of the data drift, right? So you can see the trend of the drift, the magnitude of that drift with respect to features, with respect to different distributions, and with each feature, what is happening in real world data. So right now it is not in an extensive mode, but I think they will bring more things here. So you can see the metrics and alert part, or even you can trigger this event which will lead to your CI pipeline that will trigger a job. Yeah, but more has to come in terms of the data
Got it.
drift, respect to image, uh, text, and all.
Got it. Got it. So I think this question you answered it from Bharat. When do we go for model retraining? It's typically like when you get a new data, you want to do it, or when you see a drift in your data or model, right? You have anything to add on this, Srijit? You already covered some
Right.
part.
No, you are absolutely right. The this data drift is very important, right? So many times I see that okay, fine, we build a model. Productionizing the model itself is a big thing. So we productionize the model and we leave the model there. That is not the thing. It is just the beginning, right? So this data model, post model deployment and more post model monitoring is very important step. And if we enable this kind of a data drift pipelines post deployment, right? That pipeline will give you indications that what is going wrong with the real-time data so that you can take proactive actions, so before it is getting too late. So that there comes your retraining. So you have to get in, you will get an intimation something is going happening with the data, real-time data. So you have to get in and you have to do your training experiments or whatever EDA and all. You might need to retrain and you might need to deploy a different version of the model, but this is a very important step which we usually don't do.
Right, that's true. Yeah, and it's very important. Right, sometimes like you develop your model with 5 6 months old data because in some business process the time to get the actual labels is going
Exactly.
to take take a credit card fraud. A customer is not going to complain immediately. Sometimes you see statement after 2 months and maybe complain. So your
Yeah.
model can get drifted as soon as you deploy as well. So that's why we need to have that MLOps capability built in
Yes.
right from the
Yeah.
day one.
We usually talks about retraining and continuous training, but we don't know how to set it up. So the data drift pipeline, if you set it up right, that will give you an indication that when to retrain and what to retrain. So that is the actual scope, right, end to end.
Right.
So everybody talks about that, but so that pipeline data drift is the pipeline, so where we can retrain and go for continuous training.
Got it. Got it. And the next question is similar, right? Like this is again a very sensitive topic. How do we do incremental training? Because when you do incremental training, your existing model itself can be having a complete different distribution change, right? Because the new data is coming in can completely be different. Have you seen any scenarios for incremental training? Frankly, in my experience, I have really not seen much incremental training because most of the clients or most of
Uh,
the scenarios we work with is with the banking, and we typically don't do incremental training because we have to go through entire governance process and all this stuff. You go ahead. Yeah.
I also having gone through this incremental training. That's what, right? So all these concepts are there, but I haven't practiced this incremental training. But continuous training I have done using this post deployment pipeline. Once I couple of months back, once I one of my model went to production and deployed this using this pipeline. So we just retrained some of the models recently based on this data drift indications and all, right? But incremental training I haven't done.
Got it. Right. Next question is from Roshan. Do we always have to deploy the model? I mean, once we register the model, can we download it and use that for batch scoring without deploying in ACI AKS?
Yes, that is possible, right? So if you, it is not mandatory. So if you come here in models and you can go to artifacts and you can see the PKL file, right, or the model which you created using your training script which you executed in your CI, and you uploaded that into this workspace, right? So you can simply download this and you can load this PKL file offline and you can do without deploying it into Kubernetes. It's possible.
Yeah, just make sure you don't use any Azure's inbuilt machine learning algorithm, or I'm not sure even if with that you can do it. Maybe they provide a libraries offline which you can download and deploy and do inference.
Yeah, Azure inbuilt algorithms, if you use, I don't think you will be able to do that. But if you go with any external libraries, I think so. If you
Got it.
go
So,
to,
Ashit, yeah, good. So, Ashit, we already discussed on the retraining approach, so I'm going to skip that question. Okay. So, next question is Ravi. When you say which data is used in a run, does it mean it uses a portion of 80% of the training data from the 80/20 spent from your file? I
right.
think you're more talking about data tracking, right? Go ahead.
Yes, 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 right. So here, if you go to our workspace, right, blob storage. Okay, so let me go back. Yes, this is our storage, right? So here I just logged my raw data. Okay, so the input CSV file which I used for training, right? That's what only I logged through my training script. That's what you can see here, iris data and this iris.csv file. This is the input CSV file which I used. But as I told you, right, this is the raw data, or maybe this is the process data. So if you are creating multiple types of data, process data, feature engineered data, and I just split it on a train test split, but I haven't logged that train and test CSV split data into my workspace. But you can do that as well. If you do that, then along with your raw data, you can organize it, right? So you can say um, in this blob storage of this workspace, you can say iris data. Inside this you can create a folder row and put iris csv here, and you can say train test split, and you can upload your training test split what you are doing here into that repository as well. So but I haven't done that, but you can do that. So all that, those kind of versions and everything is managed here. So it's up to you what to log data, raw data. If you wanted to do all the data, that is possible, but I haven't done that. I have only uploaded the raw data, but that is possible.
Got it. Got it. So I think this is an interesting question from Sumit. Can we use Databricks here in the pipeline? If yes, how?
I haven't done that. I need to check as well, right? So, but my understanding is this has complete this machine learning workspace. If you look at the dataset concept, right? So this dataset is a completely abstraction about or on top of whatever the data services available there. So you can bring in any type of data, but Databricks I haven't tried, but definitely there is a way to do that. To execute your training or something in Databricks, it might be possible, but I'm not sure exactly. Need to check that.
Yeah, because again, the compute instance will also come into play. Right? Databricks has its own manage
Yeah,
environment. So how do we integrate that? But that's an interesting thing.
yeah,
Like because a lot of machine learning jobs we develop using Spark and others. If we
right,
can
right.
implement that, yeah. Mm,
Definitely, there will be an integration.
mm. So again, a question from Ravi regarding compute. My assumption is to create a pod of your model image and deploy in a node in KX. Repeat it when you have any drift. Uh, Please let me know if my assumption is correct.
I don't know how it related to Drift. Okay, so your deployment in Kubernetes, it doesn't relate to your Drift actually. So Kubernetes deployment is to scale your model, scale your deployment based on the resource availability and the resource crunch, right? But it doesn't relate to your data drift actually. So if I show you the AKS AKS configuration. So here what I mentioned is minimum replica of one node till maximum 10 node is required for this deployment. And when to create a new node, right? It will always start with one. So when to go to second, when to create three, I provided a target utilization. So if one node's target utilization in terms of memory and processor is reaching beyond the 80 percentage of time, then it will create a new node. This has nothing to do with the data drift actually. It is we are managing our endpoints. We are making sure that our endpoint is scalable and fault tolerant. So it has nothing to do with the drift.
Mm. Got it. Got it. I think like let's a lot of questions. Let's go a little fast so that like
Okay.
we need to cover. So I think like can we use Azure functions as RESTful API endpoint with Databricks model? I think it's a regarding
Yes.
Databricks, but I think
Yes.
you can check for ML flow as ML models, where you can deploy some of the Databricks models outside of Databricks as well. Should be
Right.
possible. You want to add anything?
So in one of the project, right? So we created an endpoint like this. Okay. So we created an endpoint like this, and we don't want to share this endpoint URL. So there is an application. They need to call this endpoint, but we don't wanted to share this endpoint URL as it is to that application. We wanted to abstract it. Okay. So to abstract that, what we have done is on top of this endpoint, we created an Azure function. So the application will always talk to that Azure function, and Azure function internally talks to this endpoint. Like that way we have done, but not using Azure Databricks, but definitely that link is possible.
Got it. Got it. Um, Thank you again. Like people are telling, it's amazing sessions, Srijit, and really it was pretty
Thank
great
you.
to understand the end-to-end process. I think Ravi, we discovered this one. Why are you creating compute in your pipeline? In case if you want to manage infrastructure as well, otherwise you can create it separately and attach it. I think Srijit showed it as well.
Yes, yes, right, right.
Mhm.
I'm just trying to include all that possible aspect into my integration pipeline to showcase everything can be fully automated end to end.
Got it. So can you explain on how Azure handles model drift? You have shown that in pipeline, but more explanation would be helpful. Balaji, I think like you want to add anything more? We covered this as well.
Yes.
Did you want to add anything more on this one?
So I think you can go through this Azure data documentation. So what they usually do is they have different parameters, and you can set the parameter and a threshold on a deployed model. And if anything goes, they will continuously sorry, you have to enable the real-time data capture as well on top of that endpoint. Once you enable that, it will create a CSV file on the fly on a time based daily or a weekly. They will consolidate and they will create a CSV file, and that CSV file has been picked up automatically if you created a data drift indicator, and they will compare automatically in the background. And if something goes below or above the threshold, what you can define that constraint, then you can set alerts and notification, but more details you can find it in their documentation, but definitely that is there.
I think next question is Sagar. Sagar, the use case that we used is Iris dataset, but the real problem that we are trying to solve it as a MLOps using it, right? So that was the core purpose of this particular session, not the use
Right.
case. Show how you
Exactly.
do a continuous integration and continuous deployment pipeline.
Yes, exactly.
This is a nice, interesting question, right? So, does ML Flow provide any advantage over Azure ML Experiment? What is the use of ML Flow if you have everything here? So, I'm just seeing the interface, right? It looks like ML Flow to me. Are they using ML Flow or they have their own Azure experiments?
I think there. No, I have seen you can bring in ML flow as well, right? So since it's a framework, you can use this one, or you can even in your experiment, if you don't wanted to use any of this capability. Uh, I think they have abstracted a lot of APIs on top of ML flow. I don't know, but you can, if you don't wanted to use that abstraction, you can still use ML flow within this pipeline as well in your training script. But I'm not exactly sure. But
Got it. Got it. Because when I saw the interface, right, it looks almost like ML Flow experiments,
exactly.
artifacts, and all.
Exactly. But here, right, so ML flow covers one part of it, right? But here in Azure, right, they completely have an holistic linkage between all the things, right? Starting from the data till the model deployment and everything in a beautiful way. So that is the advantage.
That is true. That is true. So, but the code and resources are shared. I will add it in my YouTube video comment as well after this particular session. So you can see it over there. But all the code and resources links were given initially. If you scroll up the chat, you can find it there as well. Uh, Ravi, we this DevOps and MLOps, right? You check my previous session that I did last week. Now the MLOps is nothing but plus ML plus DevOps. So it is not like if or it is additional capability because model also have tracking of data set, tracking of experiments, and multiple other things. You can check my previous session on that. Right. And Ravi here, Ravi is saying thanks. Monitoring is a fantastic feature in Azure. What next question is from Vaishak. How to do data processing and feature engineering for new data while doing the inferencing? We should do the coding in raw data function and how to incorporate the training data stats like mean, etc. here.
Right, right. So, see, same way, right? The raw data, you can do all the things in your raw data, not the raw data actually. The method name is run. So inside that, it is like a normal Python function, but you have to keep this template. That's all. Inside that, you can do whatever it is, and from where to take your feature details, what you have calculated before, you can log all those things as part of your model, right? So when you register your model, you can create all that artifacts as a physical file or something, and you can put that as part of your model itself, and while downloading the model you will be able to access that in this scoring script, and you can make use of that.
Got it.
So right now I just created a pkl file. So inside the pkl file you can create, if you have some mean, median, mode, whatever it is, the feature computations you have applied on your feature, that has to be applied on your inference data as well, right? So you can capture all those things and you can put it into that model artifact, and that will be available here in the scoring script.
Got it. You can also use scikit-learn pipelines so that some part
Exactly.
of the feature engineering is also captured over there.
Yes, yes, right, right.
So is there any provision for feature store in Azure ML Workspace?
If you try to compare the same from a SageMaker to here, there is no specific concept of feature store in Azure ML. But SageMaker, they are saying that you have feature engineered one items, and you can, they specifically call it as feature store. But here it is not there. You have to club it with your input data, or you have to club it with your model artifact, and you have to use it. There is nothing specific like feature store in Azure.
Got it. Now, tell me one thing, right? Like Srijit, I have seen you for quite long, and you are also like an expert in the Elk stack, right? Elasticsearch,
Yeah.
Logstash, Kibana, and all. So, how do you see? Like, does it some of the functionality that we do when we are monitoring the model or monitoring the data in live production is generate KPIs out of it, take all the logs that are generated and move it to Kibana dashboard. Uh, does it require over here, or Azure ML also provides those kind of monitoring capability?
No, no, it is not here, right? So post model deployment, we used to have two things required, right? One is, for each of your deployed model you have to create a model monitoring dashboard, right? So we always say human in the loop, right? And there should be a human feedback system on top of our predictions, and that we need to take, and we need to take that as per our continuous training. We used to say that if you bring this Kibana kind of a thing or a dashboard on top of a deployed model, and uh, uh, putting all your inputs, predictions, and whatever details are available there, and if your UI has a capability for the business people to come and correct your predictions, right? So that there comes the human feedback, right? If you simply have a Kibana dashboard, it is just an analytics purpose, it is good. We
Right.
can say that, okay, fine, you have probability distribution. What is the top predicted code over a period of time? What is the input, row input, and output? Everything can be seen. But what we have done is we created custom UIs on top of this model, and we enable that human feedback loop as well, right? So you can see everything, and the business people can come and correct the predictions, so that we have a real time corrected predictions from the model, and that will get stored somewhere as a CSV or something. We have a pipeline that will be taken for our continuous training. So if we simply say you have backend system, everything is stored there, you just download the CSV and correct it to people, right? They will not use it, they will not do it. So, but if you put it in a beautiful UI where they have to simply come in and click on some buttons, and everything has been abstracted, then at least we will get some human feedbacks, and we will better use it for our retraining. So we have that part is model monitoring, and the next part is data drift.
Got it. Makes sense. So there are a lot more. Like typically, what happens when we think of MLOps, it's not only the continuous integration, continuous deployment, continuous training. There are some systems that needs to be outside of it because you don't want to say business that okay, all this is there in Azure MLOps. Go. You need to give them a facility to see the
Correct,
KPIs, go and fine tune the outputs and everything.
correct, correct.
Okay. So I'm going to literally like go a little fast. We have too many questions.
Okay.
Let me see. Like I'm going to pick and choose questions which are not answered. Um, okay, I guess monitoring is handled by application insights. I'm not sure application insights. Is there Azure service or
Yes.
something like that?
Yeah. So, but application insight is there where you can see all this kind of a input request coming to this model and basic statistics around it, the latency, throughput, and all. But you will not get such kind of a dashboard where Srivatsan was talking about, like a Kibana dashboard, where you can see the input predictions, output predictions, and its probability scores and all, right? So, you'll not be able to see that, but yeah, definitely you will go to application insights and you will get many things regarding your endpoint, what is happening over there. But that is not the model monitoring dashboard. That is for the business people, not for the developers actually, which we are talking about, right?
Got it. Got it. So there's a question from Ravi. Does Azure DP under certification test the knowledge of what you have covered today? Or is there any Azure certificate that covers it?
So same DP100. DP100 will ask you all about this workspace, all these terms they ask, and they will ask some kind of a scenario, what to select what. Uh, Primarily, this DP100 is based on that because I had done DP100 last year. So it's all about this. If you just go through, have a free trial session of this and go through this workspace, you will be able to do that. It is better because they mostly ask for practical questions.
Got it. Got it. I think, is there any labeling service in Azure? I think GCP has a labeling service. Does
Yeah.
Azure have any
Yes.
labeling service?
Yeah. So here you see that data labeling is here. So we can create a data labeling project and you can do the data labeling here. And this notebook always comes with the notebooks. So if you wanted to do all your development environment here, you can create a Jupyter notebook here instead of going through a VS Code and usual Python coding. And you can have an automated ML here. If you wanted to try out some auto ML with this, you can do that. And there is a designer where you can create drag and drop options with all the Azure components, but I usually don't prefer this. So you can do that. You can select a data set and drag and drop and connect the links together. Everything is available in your workspace. Yes, data labeling is also there.
Got it. So how does the old model update AKS with the new model? I think like Srijit mentioned the score.py as a version as well, or it will take the latest version. Go ahead, Srijit.
Yes, right. So here in the score.py, right? So here you can see I am selecting a model name Iris, right? So if I just specify a version of 5, it will pick up the model version of Iris 5 from the model registry, right? So if you look at the model registry, it will have all the models in a version format, right? Iris is the name and version 1. So here it is, we are only having one. Assume you have 5 versions. So if I say Iris 1 in my scoring script, then it will pick the first version of the model. If I don't mention the version, then it will pick up the latest version.
Got it. Got it. I think Rohit, we answered this one. I think in Azure, basically you can create compute instances which is in production and you can use it. Even though like at that time we did not get the question and asked you to type it, but I think like it's the same answer, right? You can create your compute instances in production and get the data and then use it to train over here. And all the security groups and everything you can still manage. Right.
Right, right.
So Sumit is asking, so data scientists need to be equipped with all the DevOps skills to be able to work on MLOps framework. So not really, Sumit, right? Like you will have a team of people doing it, but in some small companies, right? Like or when you're doing a prototype, when you're doing a POC, it becomes like part of our job, right? Now, one good thing what I have seen, see the it is not only like all the technology tools that we are seeing; it is also a process. If my data scientist is not writing clean code, then he has to also follow some kind of nice guidelines process that we set. So it's a team that come together and make it happen. You don't have to be master in it. You want anything to add on this, Srijit?
Nothing serious. And so, because, yeah, as you rightly pointed, right? So, in my project, I had to do this end to end. model training, building the pipeline, CI/CD, and everything. So I had to go through that. But if you have a flexibility of having multiple teams, then you don't need to master it.
Got it. Uh, Yeah. So I think that's it. That's a set of questions we have, Srijit, right? Thank you for your time. Really, it is almost more than 1.5 hours. Thank you for the patience in taking to the entire flow, also answering all the questions. Thank you very much. I might have skipped some questions, but if you still have doubt on that, you can put it in the YouTube comment and we will try to answer it. But again, thank you, Srijit. It was a wonderful session and very insightful. And frankly, I'm not from Azure like cloud person, but I learned a lot. Because the way they have streamlined the process, the way they have done end-to-end model training, it was really amazing on Azure. Thank you very much, Srijit.
Yeah, thank you, Sivatsan, for this wonderful opportunity, right? So thank you all for listening, right? So thank you very much.